Most standby generator set systems are arranged to start automatically when the utility or primary power to the system load is interrupted. Interruption can be caused by numerous reasons, such as weather or equipment failure. Many standby systems are there to provide backup power to critical life and/or economic load, such as hospitals and telecommunication stations. Typically, an automatic transfer switch, most frequently called an ATS, is used to transfer the load between the primary power source and the standby generator set. As this animation shows, utility power normally flows through the ATS contactor that connects the utility to the load. In a power failure, the utility contactor is de-energized. The control panel senses utility failure and signals the generator to start. When the generator has reached full voltage, the generator contactor is energized and closes the supply power to the load. The utility and generator contactors are mechanically and electrically interlocked to ensure only one power supply can be fed to the load. The ATS is a very important component within a standby system. To ensure continued reliability, the ATS unit should be regularly maintained as part of a planned maintenance program. It is crucial to ensure all contacts are maintained in a good condition and their interlocking mechanisms are in full working order. Planned maintenance of an ATS unit must be carried out only by experienced and qualified service technicians. Such technicians are found within a reputable distributor specializing in supplying and servicing standby generator systems. During an ATS planned maintenance service call, the technician will brush and vacuum any dirt or debris from inside and outside of ATS and never use compressed air to remove dirt or dust. Check the operation of the transfer switch before beginning service. Check timers controlling the time for transferring to the standby power supply and the time before returning power to the utility. This avoids several transfers when power is going on and off or only interrupted for a short period. Check the remote contact that provides the signal to the generator controls, indicating the status of the utility supply. Check for any voltage drop across the contacts that would indicate poor condition or a fault. Use an infrared thermometer to determine contact condition and whether a poor condition is resulting in too much heat. Record any voltage drop found when the generator is connected to the load. Note in the maintenance log the temperatures across contacts. Place a lockout tag on the power source. Check the connections and torque tightness of normal, emergency, and load connections. Check the condition of air insulators. Check the condition of main contacts. Check the main power, mechanical operation, and integrity of the ATS switching mechanisms. Check the condition of auxiliary contacts. Check for evidence of arcing, hot spots, or other damage to the ATS. Check and lubricate the switch and look for any binding. Check and retorque the ATS mounting hardware. Check and retorque the ATS contact mounting. Check, inspect, and clean the controller and its relays if fitted. Check the calibration of the voltage sensing circuitry and set points and recalibrate if necessary. Check solenoid valves for proper operation, if applicable. Prior to re-energization, verify the manual operation of the switch. Remove the lockout tag. Once done, the generator can be started and the circuit breaker connected to emergency load. Finally, the technician will check and reset all switches in their correct position. Planned maintenance on your ATS ensures in the event of a power outage, power can be reliably switched over to your standby generator set. Make sure ATS maintenance is always part of any planned maintenance service call.